everyone. I am Dr. Anubha Gupta, Assistant Professor in ABES Engineering College. Today I am going to discuss fringe width derivation for wedge-shaped thin film in interference in physics. So the content of my topic, wedge-shaped film. What is the wedge-shaped film? First of all, I will discuss. After that, expression for fringe width in wedge-shaped thin film. Wedge-shaped film. What is a wedge-shaped film? When two surfaces, you can see in this diagram, there are the two surfaces OA and OB are inclined slightly on each other and encloses a film of refractive index mu as shown in figure. This is the film of any material which has the refractive index mu. This is the refractive index mu. Suppose these are the two glass surfaces and some transparent medium is enclosed between these two surfaces. In a wedge-shaped film, the thickness of the thin film is increases gradually. The thickness of the wedge-shaped film increases gradually. The thickness of the thin film is 0 at the point of contact, and it has the thickness T at the end point. So we will incident some light on the first surface. Suppose the light is SP. This is the normal PL. The light is incident at the angle theta. At the angle I. Then the light is refracted at the same angle, which is the angle I. And the some part of the light is refracted at angle R. Then some part of the light is reflected from the lower surface. So I am explaining it again. Let us suppose that the monochromatic light is incident on the upper surface of the wedge-shaped film. LP is the perpendicular. Some part of the light is reflected at the same angle, but the some part of the light is refracted from the lower surface of the wedge-shaped film. Then this is the type of interference, and the interference occurs between the ray 1 and 2. Then the main monochromatic light is divided into the two parts. This type of interference is the division of amplitude, not division of wavefront. So when we will view the these are the two coherent sources. They make the two coherent sources. When we will view the interference phenomena from the upper surface, then we will observe there are some fringes are formed. So we will find the thickness, the fringe width of the fringes which are formed due to interference. So to understand the phenomena of fringe width, let us firstly discuss the phenomena of interference for maxima and minima. For maxima, the path difference between the ray 1 and ray 2. This is the angle I. This is the same angle I. This is the angle R. For the maxima, we know that the path difference is 2 mu t cos R plus lambda by 2, which is equal to 2n lambda by 2. But due to the perpendicular incidence, the angle R is very, very small. So cos R is approximately 1. So we will only use 2 mu t plus lambda by 2 is equal to n lambda for the maxima. And 2 mu t is equal to 2n minus 1 into lambda by 2, where n start from 1, 2, 3 and so on. And for minima, the path difference between the two ray 1 and 2, 2 mu t cos R plus lambda by 2 is equal to the odd multiple of lambda by 2. Then it will be equal to 2 mu t cos R is equal to 2n lambda by 2. This is condition for the minima. Now, again, the cos R is equal to 1 because R is for the perpendicular incidence. Then 2 mu t is equal to 2n lambda by 2, where n is equal to 0, 1, 2, 3 and so on. So we will use these two conditions for finding the fringe width. So what is the fringe width? Now I will define what is the fringe width. These are the fringes which we are observing due to the interference between the two coherent waves. And the two coherent waves are obtained due to the division of amplitude from the upper surface and lower surface. So fringe width is the distance between two successive maxima, or the distance between the two successive minima. Let us start. This fringe has a thickness T from the point of contact. And this is the fringe, nth fringe. Now further, there is another successive fringe which has a distance xn plus 1 from the point of contact O. The thickness is T2. And the thickness of this fringe is T1. And the thickness of this fringe, n plus 1th fringe, is T2. And this is T1. So what is the tan theta? And this angle, this wedge angle, is called the angle theta. So according to the tan theta is equal to T1 upon xn. So I can easily calculate T1, value of T1, which is equal to xn tan theta. Now, the value of, this is the value of, okay, we will write it again. The value of T1 is equal to xn tan theta. Or we can say that xn is equal to T1 upon 10 theta. Similarly, xn plus 1 is equal to T2 upon 10 theta. Now we know that fringe width is the distance between the two successive maxima or two successive minima. So the distance between the nth fringe and the n plus 1th fringe, this is the xn distance and this is the xn plus 1. So the distance between the n plus 1th fringe and nth fringe is xn plus 1 minus xn. So we will put the value from the this formula. We got xn plus 1 is equal to T2 upon 10 theta minus T1 upon 10 theta. Now, as we know that the condition for the minima is 2 mu t is equal to 2n minus 1 lambda by 2. This is the condition for maxima, and the condition for minima is condition for minima. 2 mu t is equal to n lambda. But for the nth fringe, the thickness is T1. And for n plus 1th fringe, the thickness is T2. So we will put the value of T1 and T2 in this equation. T1 is equal to n lambda upon 2 mu. And T2 is equal to n plus 1 lambda upon 2 mu. So put this value in equation number 1. It becomes n plus 1 lambda upon 2 mu, value of 2t, and we will put the 10 theta minus then value of T1 n lambda upon 2 mu 10 theta. After taking the common and after solving it, we got lambda upon 2 mu 10 theta. So the fringe width formula is lambda upon 2 mu 10 theta, where theta is very small angle. This angle is the wedge angle, which is a very small, 1 degree, 2 degree, and very small, less than 1 degree, half degree. So we can write the 10 theta as theta. So fringe width formula for the wedge shape film is lambda upon 2 mu theta, where theta is wedge angle and which is very small. Mu is the refractive index of the film which we are using between the two surfaces. If between the two surfaces there is an air, then the fringe width formula is lambda upon 2 theta. It is a lambda upon 2 theta. So finally, fringe width in a wedge shape film is lambda upon 2 mu theta. It means fringe width is directly proportional to the lambda, inversely proportional to the mu, and inversely proportional to the angle of wedge. So now we will do some numericals. Let light of wavelength 6000 angstrom falls normally on a thin wedge shape film. 6000 angstrom. And the mu is 1.4. And the fringes are 2 millimeter apart. These are the 2 millimeter apart. Find the angle of wedge in second. So we know the formula which we will use is a formula for the wedge shape film, because in the question there is a clear-cut instruction wedge shape film. So fringe width formula is lambda upon 2 mu theta. And the fringe width already 2 millimeter apart. So I will write in a meter. It is a 2 into 10 is the power minus 3. Lambda is the wavelength. I will convert into the meter 10 is the power minus 10 upon 2. Mu is the refractive index, which I will write as a 1.4, and theta is the angle. We will get theta from here. After calculation, the theta is, so after calculation, we will got theta as a, in a radian. In a radian, theta is 10.71 into 10 to the power minus 5 radian. So we want the angle of wedge in a second. To convert into the degree, 180 upon pi. Multiply by 180 degree upon pi. So from the radian, we will switch to the degree. So theta will be 0.060061 degree. You got the answer in the degree. But when the answer is in degree, then convert into the second. Theta is equal to 0.0061 degree. Show all the steps. Then to change the degree into the second, we will multiply by, first we will change into the minute by multiply 60. Then again we will multiply by the 60 and it will convert into the second. Then theta will be 21.96 second. Theta is equal to 21.96 second, or approximately you will get 22 second. It will also correct. To solve it. Second question. Two plane glass surfaces in contact along with one edge are separated at the opposite edge by a thin wire. If 20 interference fringes are observed between these edges, these are the 20 fringes. Total, these are the 20 fringes. What is the thickness of this wire? What is the thickness of this wire? So, firstly, what is the theta? We will go for the fringe width formula. Fringe width formula is lambda upon 2 mu theta. We will use the fringe width formula lambda by 2 mu theta. Then put the value. So this is the, now we will put the values. Now there is a no theta is given. So find the theta. We know that the angle is equal to tan theta. We can write the tan theta as a theta. If the theta is very, very small, then tan theta is equal to perpendicular upon base. So perpendicular is the thickness, which is the T. And one fringe has the width x bar. One fringe has the width x bar. There is a 20 fringes. So it will be 20 x bar. Because this is a 1x bar, this is 2x bar, 3x bar. Like this, there is a 20 fringes. And the distance between the one successive fringe is the x bar. So 20 has, so we will write the base as a 20 x bar. Put the value of theta here. X bar is equal to lambda upon 2 mu. Put the value of theta. T into 20 x bar. After solving it, cut the x bar, T. T is the thickness of the wire. So T, for finding the T, this is the lambda. Means there is some wire like this. This is the wire like this. We are putting the wire like this. So this is the thickness of the wire. This is some wire. You can imagine it. And lambda upon 2 mu. Lambda is given. It is in a question, lambda should be given 20 fringes with the sodium light. Sodium light of the normal incidence. We know that the standard value of the sodium light is 5890. If it is given, then it's okay. But it is given that what is the source? We should remember the value of the lambda. It is a 5890 angstrom upon 2 mu. Refractive index of the film. Interference fringes are obtained. So if there is no mu is given, it means there is a air, and the refractive index of the air is 1. So calculate T is, okay, but here we have the 20 also. So the thickness of the film is 58900 angstrom. 58900 angstrom. Or in a centimeter, it is a 5.89 into 10 this is the power minus 4 centimeter. So this is the all in all for the today's lecture. Textbooks which I refer, textbooks of optics by Brijlal and Subramaniam, and the optics by Ajoy Ghatak. Thank you so much.